Hello everybody, welcome to another stream. How are we doing? Hey there, the ugly dev, welcome. Yeah, it's been a while. Yeah, I went on a holiday for a whole month, went to Australia. So I literally been back, I've been back over a week now. So, yeah, it's been good. Just had a nice long break basically. I didn't do programming for a whole month, which is pretty crazy. Went outside and saw lots of different things. Awesome. Yeah, I'm glad to be back too. I did miss being home after a while. I was yeah, was quite entertained though. By the way. Hey Dax 3022, welcome. Namaskar, whatever that means. Namaskar. Sandro, it's been a while. Yeah, it's been a while, man. How you been? Definitely haven't seen you since I've been back. So, end of last stream, let's do a quick recap. We got all the volume constructor shaders compiling. But at the end of my compiler, it outputs a SPIR-V binary. And what was happening is I was doing stuff like this. Wait a minute. Yeah, I did that. So in C, this converts to an integer. The comparison operator converts to an integer, but for some reason in my compiler, probably because it wasn't initially C, and I converted it over to being C. It was meant to be a C-like shading language, and then I was like, you know what, we'll just do proper C. So this actually converted to a Boolean type. So then in the SPIR-V, it kind of errored. I was thinking, this is not good. So the reason why it errored is because SPIR-V, when you do a, it's called like a bounds, a pointer access chain. This is basically get element pointer and LLVM, but it allows you to get like all of your, all of this expression turns into one of these instructions. And it basically says, compute me a pointer from the base address of this, given array indices, field accesses, more array indices. And this was a Boolean type and not an integer. And it says here that it has to be the indices, right, of the arrays and whatever have to be integers. So I kept digging in and finding that the Boolean type in SPIR-V reads as enhance. Oh wait, I lost it now. Reads as the following. Values can either be true or false. There is no physical size or bit pattern defined for these values. So last stream I was sort of just what was I doing? I forgot what I did in the last stream now, but anyway, off stream, basically I decided that we will not be using this op-type boolean because it's basically just a very crap constraint. It doesn't say what size it is at all, so I can share code between CPU and GPU, but if I use the Boolean type as it was implemented, it still wouldn't work. Ideally, you want it to be a byte, right? Because it's a byte on x86 and probably every other architecture that you care about. So what it is now is just a signed 32-bit integer type. That's what I've changed it to being in the compiler. So I've got this change up on the GitHub for the HCC compiler now. And I've got it all in the repo. So we switch over to using a signed 32-bit integer instead. So it's added a bit more code to the code gen because you have to keep converting from this signed 32-bit integer into a SPIR-V Boolean when you want to do anything like a branch conditional, which is basically an if statement. Yeah, when you use a branch condition, your condition must be a Boolean type. And when you do like a select statement, which is your ternary operator, right, the condition has to be a Boolean type. So we have to convert these signed integers type into a Boolean type in the SPIR-V code gen, but hopefully that's all right and it doesn't kill performance too bad. We'll see. Should be all right. So what was it? Yeah, so to do that, basically, before any of those branch conditionals, we do a not equal. It's called an I not equal, isn't it, for integer, or F not equal for float. So we'll do one of these guys, which convert with the first operand being the Boolean, the integer Boolean, and the second operand being a 0, right? So if it's not equal to 0, it is true. And I'll convert it to a Boolean for SPIR-V to be like, oh, it's the correct type. So the downside, so the good thing about this is now a Boolean is a defined size. The downside is that it's different from x86. It's a, yeah. So this expression now behaves like it does in C, right? This returns an int now. Right, and that's awesome. This expression returns an integer, but the specific Boolean type, that is also just an int, but it's special. Where if you do if you cast in C, if you cast anything to a Boolean, if it's a non-zero value, it is true. So this means 0.5 is a non-zero value, it is true. Whereas if you cast that to an int, it truncates down towards 0, which means that would be a 0. So yeah, Boolean is always 0 and 1, but the internal representation is a 32-bit integer, so it's different from x86. So if we put Booleans in data structures, we have to be careful that we don't share them between the CPU and GPU code now. So yeah, so that's the changes I've done off stream. Basically, is get the Boolean to be proper, get it to be like a and get the comparison operators to be the right type. So now our shaders are compiling from last stream into an actual binary. They were compiling syntactically and semantically, but not outputting the binary, and that's what I fixed off stream. So now we're going to be going over the 4 shaders and getting them running. So we'll go over and explain them as we go to get them running, basically. So I want to first start off by just getting the CPU side compiling, and then we'll tackle the shaders one by one. So let me open up this file in another tab, because we love our tabs, right? So yeah, we don't have a volume spheres array anymore. That thing has been nuked. Yeah, that tile binning stuff needs to get sorted out. We're not doing the binning stuff today. That will probably be tomorrow. Not tomorrow, Tuesday. In the next stream, I mean. What is all this? Right, it doesn't seem like we've got a lot to actually fix up. Yeah, we've removed Boolean vectors from, yeah, Boolean vectors have been removed from the HCC compiler as well, because they're kind of just weird. Because you don't have bite-sized types by default. Alright, so actually all compiling CPU side. So that's good. So the first shader that we're going to get up and running is this one called, I don't know, what was it? Okay, Milton up so I can show my drawings, my beautiful drawings. And while it loads, got a nice Dr. Pepper Zero. Look at that. I like the art now. I quite like the rebranding, not gonna lie. So I'm gonna open up this boy. Oh yeah. So, um, so effectively, right, what are we rendering? A volume is a 256 cubed area of spheres, and the way it's stored on disk is not in 256 cubed of spheres, right? Because that's 16 megabytes at minimum of memory if all the information we needed was a byte. So if we have 1,000 of those, that's 16 gigabytes at minimum, just for volumes. So to save space, there's a nice little trick you can do where basically you store the history of what it took to build this volume. So currently we have these things called edits or whatever, and they're just cuboids and spheres. Sorry, cuboids and ellipse. Yeah. And you sort of paint them down within the volume, and then that will be filled with spheres. And essentially, if the spheres are, yeah, right. So there's those. And yeah, so what this shader does is it starts off at the top of the tree because it's an LOD system, right? The whole, as you can tell by the title of the stream, is we're building an LOD system, so level of detail. So L0 is one cluster, which is a 4 by 4 by 4 of spheres. And effectively, we brush the edits down in there and see if it does anything. It probably doesn't do anything unless you've done these massive edits. And then it will say, oh, have these edits brushed around in any of the children areas, right? It subdivides it into an octree, basically, of children. So has it touched any of these areas? And if it has, it will then push on the children onto some queue, and then it will go over all the edits again and see if it painted in those, basically. And the sort of edit paint job things, those can be targeted at a specific level of detail, so you can paint down at a specific level of detail. So most of the times you just skip over stuff. But yeah, so we've got a shader which basically constructs these volumes, and you do that at some load time. So this initial one just builds the initial tree, but what it doesn't do is build a lower level of detail of the sphere. So if you put tons of edits that sort of fill an area, it's not going to build the lower level of detail automatically. That's a step that comes later. That's one of the next shaders. So let's start with this one and see how we go. So what we have, so I should already put a comment in here. This is let the first thread take a job from the queue. I'll take a cluster from the queue to work on across the two wave 32s. So it's right in this thread group. Oh, I think we call them dispatch groups. Yeah. So our local size is 4 by 4 by 4, which is the size of a cluster, and so that's two wave 32s because it's 64, right? 4 cubed is 64. So this is just some multi-threaded way of grabbing from the queue safely. It's one of them, unfortunately. Maybe we can improve this in some way. We'll see how it pans out. But effectively, as a queue. Yeah, I want to see how I can perhaps improve this queuing. Like, I know I want a queue system to do this algorithm with because it seems to make the most sense. But the code around it, I want to see if I can improve that or the way I populate it and whatever. But that can happen later. There's no rush for that now. But after you got your queue, you're just effectively going over all of those edits. So the thing that I'm most scared about, is this. Like, you just got a wall 1, and that in GPU is not the best idea, because your code has got to be perfect. So since we're running this for the first time, and you should really do this anyway, that's what I means, isn't it? It's iterations, really. But what's the maximum number of iterations that we're going to actually have here? That's a good point. I want to say, so we could just put, hey, what's the maximum number of clusters that can be in a tree for a volume? And we have that number here. Is it? Not sure if that's right. Yeah, it's right. Why is it going to 6? Yeah, because you start off at 4, isn't it? Yeah, you already start off at 4. So the shift left 6. I'm at 256. Yeah. That's why. Yes, that is the number. That's the maximum number of clusters. So we put that in there. That's a nice little safeguard where, sure, it's going to run for a long time and probably like still freeze up the computer. Hopefully not. Because there's this weird AMD bug we've got, right? And it's so bloody annoying. But if we have something that runs too long, the desktop, it's not the desktop environment, it's the driver. Or is it? Yeah, I'm not sure what it is exactly. But effectively, if the desktop environment, like, okay, this problem doesn't exist on Intel GPUs because I've tested it on my laptop on Linux and it's fine. But there's something to do with the driver. Maybe it doesn't give the desktop a chance to run anything in time. Or, like, because all the compute units are solely for this game or whatever, and it's just never ends. Or it's something to do in the driver code where it can just recover gracefully for when it decides to kill the shaders that have lasted ages. But if you have a shader that lasts for more than a few seconds, I think, and it uses all the resources on the GPU on AMD, it will just crash your desktop and you have to restart your PC. So hopefully this will fix that even with the number of iterations. Hopefully it'll be alright there. Hey Solly, how's it going? Welcome. How you been? So there's another loop here. We'll do that same thing. I count from 0. 1, 1, 1. So yeah, that's again just to safeguard it. Yeah. That might spin there though. That will be alright. No problem with that one. Yeah, so we've got safeguards in there before we give it a run. I think I'm pretty happy with the shader though. Right. Easy. So what we're going to do, so I'm not sure if there's a way to verify. Yeah, there is a way to verify, because what's great about this is this outputs an occupation map. So we should be able to see in the texture some version of like what's going on. But it's where each bit represents a cluster which is filled with clusters, or mostly filled. Sorry, mostly filled with spheres, that's what I meant to say. Clusters filled with clusters? What are you talking about? Right. So if we go to the CPU side of this construct leaf nodes thing, we want to disable the rest. So this clear texture, that needs to happen after, right? Oh, sorry, before. So we're clearing the... Clear the keys, clear the occupation map texture, and we're just going to run up to about here. I need to disable the rendering as well. Yeah, let's keep that running. Where's the sphere tile bin? Yeah, here's the tile binning. Let's just kill that. Ray trace tiled. Yeah, we don't do any ray tracing because there's nothing in the buffer and it'll probably just, yeah, not good. So all right, so now's the time. So if the stream does die, everybody, I'll be back. That's just the way it works with this damn AMD driver. But it shouldn't crash and burn. Oh, we might hit a Vulkan validation error because I encountered that in my sample code for the compiler. So we're probably going to hit that. Right. I think we got a crash. Interesting. Right, the stream stayed up. Very good. Yeah, so we got the validation error, but it's taken ages to get the debug info back because the DLL for the validation layer is like 0.5 GB, and it has to call on it like many times. So it's just, yeah, yeah. So basically, right, I know how to fix this one. So in the let's go to the Vulkan backend. The validation layers have been updated so they're more helpful and have provided some insight into things. And it's the acquire next image. This gives us a semaphore, right? So when we have a command buffer, we say, hey, don't fire this command buffer until this semaphore is like all good to go. And when this is signaled by this function here, or this sort of capability of the GPU, it's basically saying, hey, that swap chain image that you're going to render to for the final screen is ready for you to now actually use. So you're saying, hey, give me the next image. It gives you back an index of the swap chain image. And then it says, but don't use it until this thing is signaled. So yeah. Why is that? Why do we need to know that? Because you need a couple of these boys. What you need is you actually need 2 of them, isn't it? Something like that. DLL, that's Windows lingo. Yeah. What is a dynamic library? Shared object file doesn't really. It just sounds too general. It's better us calling everything a buffer. Hey, Majestic Mac, do you have a timeline for semaphore support for timeline support for WSS? Right, I'm not sure WSI. But yeah, I get what you're saying. The timeline semaphores. I don't think they're supported on the present. If that's what you're talking about, the present queue stuff. You have to use the binary semaphores still. Yeah, I'm pretty sure that's still true. Yeah. So effectively, you need to double buffer these. So one frame uses one semaphore, then the next frame uses a different semaphore. Because when you acquire the image, you can't tell it to use a semaphore that's signaled or something like this. I guess it's just trying to catch on an edge case. So say if the first frame one is signaled. Wait a minute. In your next frame, yeah, acquires the image, it might turn it from a signal state to an unsignaled state, and it could cause some problems actually. It seems pretty, yeah. So this is just gonna, I need a for loop. Too lazy to type. But yeah, the timeline semaphores, they're where it's at. Because the timeline semaphores just sort of give you sort of like, pretty much what it is under the hood is like some integer. And you can just say when it's equal to this integer, like, yeah, you can say like, when you want, you can basically control what the integer is under the hood of the semaphore. So you say, when you signal your own semaphores, you can say, hey, set it to value 6. And then you can say to another one, wait here until this thing is equal to 6. And it's just very powerful. Because it means you can just reuse the same semaphore and have to keep creating and destroying semaphores and just keep upping the number or something like that. It's really powerful. What was I even looking for? I was looking for a for loop that I can just copy because I'm being lazy. Yeah, one of them. And Vulkan, need to Vulkan some more active frames. How's your trip to Australia? Yeah, it was good. It was awesome. Did lots of stuff. Busy every day. Went out places, you know, all the time. Even with the baby, it was a lot of fun. Went on like walks and stuff. In like, I guess, yeah, in the woods, equivalent woods over there, I guess. Sort of up mountains and stuff. Went into the city, saw the city. Went to the zoo and stuff, saw some of the animals, the distinct animals and that. What else? Also took the baby for a swim in their sort of pools and stuff they have just in the public for free. It's just pretty great. But the baby loves swimming. Is a lot of fun. Wait, why am I putting a for loop there? Don't do that. That's not a good idea. That's what my brain not thinking. So here we need to get the current active frame. So active frame would just be like 0 or 1. Paddles between the two. I'll just get it here. So I get the right semaphore for that frame. This one was the same thing. So this is when we're saying like, hey, when we're doing the submit, we're like, oh yeah, don't trigger this command buffer until, yeah, until the previous frame. Oh, I've got timer semaphore in there. Did I use a timer semaphore? I don't think I used this yet in the code base. Maybe I have. Yeah, just do the incrementing one. Yeah, that's good. Timeline semaphores for the win. Right, so I think that's adjusted now. Yeah. Right, so that should be the necessary change. So the thing is, it did take a while to run the first frame, so it leads me to believe there was in some form of infinite loop. But we did come up with like a message. Like, desktop effects were restarted due to graphics reset. So this leads me to believe that there's like it did run for too long and it did gracefully recover somehow, which is interesting because I've never seen that happen. Maybe they fixed the drivers, I don't know. Wait, did we run the shader before, which sets everything up? I think we did. And where I'm going anymore. Oh yeah. Right, let's start off by not even running that shader. Let's just run the constructor reset in this one, just so make sure stuff is still running alright. Alright. Yeah, so the stream dies, I'll be right back. You guys know the drill. Right, here we go. Following constructor reset. We're doing a couple of mem sets of some buffers. It actually takes some time. It's alright though. And a texture clear as well. Alright. Guess they're big buffers. So now we're going to move that back down there. Now this is where it can actually crash and burn. Right, let's see how this goes. Uh-oh. We recovered. Oh my days, have they fixed the driver? That's amazing. Okay, so it didn't crash. That's amazing. Did things actually... So we got device lost, so it was running for too long. They might have fixed the AMD driver. If so, that's incredible. So now I don't have to restart my PC when this happens. Finally. Or maybe it didn't hang for long enough. So what's great is we will get to the next frame. Wait. What does part of me want to do? So the problem is this safeguard, when it leaves here, is not going to have set the cluster index upright. So it's going to do an out of bounds access on here anyway. Yeah, so maybe some of these safeguards need to be thought through a bit more. Yeah, so maybe what we could say is like, oh yeah, so if cluster index equal E32 max, then what we'll do is we'll just let's break out of that. Yeah, we'll just return or whatever. So you have to make sure you store it as that initially. So what we need to do is before we even enter this loop, we need to actually initialize it with a, and voila. So that helps there. Now, what we should also do is put some sort of printing in there. So maybe it will show up in the log if it runs for too long. And maybe we can reduce the number if it takes too long to run. What are we trying to say here? Spinning for too long, I don't know. I don't know, do you need that one though? Yeah, let's just say spinning for too long, let's just see what happens. I think I have to put a number out. Because, yeah. The way I've done this print needs another argument here or something. Yeah, I can actually make that better. Yeah, I think I can improve that. Not to worry. Wait, can I improve that now? GPU what? GPU shader. Yeah. First arg A. You just do that. First arg. Boom. Wait. Not first arg. C programming at its finest. There we go. So, yeah, that'll mean that then we can just put, we only need one arg, at least one arg in there or something like that, I think. And then we don't have to do this silly nonsense anymore, and it's just amazing. Right. Oh shoot, what did I do? What did I do? Oh, did I mess up with the parentheses? No. Oh, I did format instead of VAR, something like that. No. Oh, some of the others expect more arguments. Yeah, I think internally the actual printing code also expects more arguments. It's something very weird. Yeah, because we do like a for each over the rest of them in macros. It's pretty crazy. Okay, that's right. I'll undo my changes. So something more internal to the compiler's printf function. That's right. Not to worry. I'll just do that then. Alright, so again, if the stream dies, I'll be right back.